Hey everyone, welcome to your Play Posit for the week. I hope you guys had a great weekend. I also hope you had a great week last week. I didn't get to see you in live classes. We were in our professional development as a school, and I got to learn so many new things, and I also got to share some things with my colleagues. I held 2 sessions, one of them where I got to show everyone how to use breakout rooms in Neuro. That was a lot of fun. So we are going to be doing some scavenger hunts in breakout rooms soon, which I think you guys will find to be exciting and different, and also just a really great way to practice our math work. So today we're going to continue on through Unit 3 and get your notes ready. We'll get started. We're just going to be basically doing some practice problems around the CP-CTC, right? Corresponding parts of congruent triangles are congruent. And we know it works with triangles, but it also works with any shape. Any shapes that are congruent have those corresponding parts that match up. Before we get to that, I wanted to announce an extra credit opportunity. If you had me last year, we also did this last year. It turned out really great and a lot of fun. You guys had some really cool examples, so I wanted to do it again. So if you did complete it last year, it's a brand new link, so you do have to do it again. But it's just a pumpkin carving activity, and it's through Desmos. So you'll click this link, and I'll put the link in our Play Posit, so it pops up for you. Sign in. You don't have to sign in. Remember, you click the button that says continue without signing in, but make sure that you put your first initial and last name so that I can give you those extra credit points. You'll follow the example on the first slide and then create your very own pumpkin. Those do need to be complete by this Friday at 11:59. So remember CP-CTC. Oops, let me get my pencil. Corresponding parts of congruent triangles are congruent, and it works with any shape, but in this unit we call it CP-CTC. So this right here, remember what we call this? It's a congruence statement. So this symbol means congruence, congruent to. So let's say we put F, L, X, and Z, A, Q. So we can use this congruence statement to mark up the triangles and match up the parts. So angle F is going to equal angle Z. F and Z. See, because those letters are in the first position, so they match up. Just like L and A. They're both in the middle, so they're both congruent. And lastly, X and Q. These are congruent. It doesn't really matter how the picture's drawn. Remember, pictures are never drawn to scale. You want to follow the congruence statement. So let's mark the side lengths. We have FL is corresponding to ZA. Give those 1 mark. And then LX and AQ. And then lastly, our third side, right? FX and ZQ. So just a reminder of how that congruent statement works. And the reason it's so powerful is you can be given a problem like this where they want you to match up the other triangle. So they say EDC. We have to make sure we go in the same order. We want to match angle E. So angle E is 79. Let's find 79 over here. And it matches with W. So W must come first. And then angle D, that is 63. Here's our other 63. So we're going to have X. And lastly, C and Y. So that's kind of like a backwards way of working with congruent statements, taking the picture and writing the congruent sentence. Here's another example. Remember, at any time, even if I don't have a pause built in for you into the Play Posit, you guys can press pause and try these on your own. I highly encourage that. So let's see, they have N, M, O. Let's use the side lengths this time. We start with N and we go to M. That's the 21. And then it goes to O. So it goes this way to the 27. So it goes 27 to 21. So we need to go the same order, right? 27 to 21. Oops. I just said that and did that totally wrong. Hold on. So we want to go the 21 to the 27. So 21 to the 27. All right, I wrote it right, said it wrong. So you want to go in the same order on both triangles. So we're going to go V, W, X. And you're done. You can check with the angles if you'd like, since they are there. N is 59, V better be 59, and it is. And so on. M is 78, so W should be 78. Yep. All right, now we're going to start solving for missing things. They give us the congruence statement and want to know the measure of angle W. So let's see, here's W. And we can't just get it from this triangle, right? Because there's only one angle. If we had another angle here, we could use the triangle sum theorem. Remember that, where they all add up to 180? But we don't. So let's use the other triangle. W matches up with which angle? Q. So they are the same. So what's Q? Q is 63. So that means W is also 63. Example 4, same idea. Let's find the measure of angle E. Here's angle E. Ooh, this one we do have two angles, so we could use the triangle sum theorem. Let's try it. So 53 plus 37, right? These two angles add up to, old school addition here. I don't have my calculator handy. You could get your calculator if you want. 90 degrees. Okay, so two of those angles are 90 degrees, which must mean angle E is also 90 degrees, right? Because then we take this and subtract it from 180, and you get 90. That's that triangle sum theorem. So it's 90 degrees. Or it tells you they're congruent. So we could try to match them up, but that's a little challenging. Let's see. We would match it up with the side lengths since we have all three. Let's see, 30. So if T is 53, that must match with D. And since V is 90, then we know U must be 37, right? The other marking. So then that's why V and E, those match up. These figures are congruent. What is the measure of angle R? So here's angle R. Excuse me. Angle R is across from Q, angle 56. So we could come to this triangle and say, well, what's across from 56 over here? Oh, it's 34. So it's got to be the same in both triangles. So because we know they're congruent, even though they didn't give us the congruent statement, since we know they are congruent, we can also use those visual tools. Oops, so it's 34. There we go. Now they have the statement. What is SQ? Here's our triangle with SQ. We know nothing about SQ. There's not a single measurement. Except we do know it's congruent to this triangle. So all we need to do is figure out which side matches with SQ. Well, S is the last letter, Q is the first letter, so we're looking for HF. Here's HF, 33 inches. It really comes down to being able to read this congruent statement and obviously understand what it means, right? Are these shapes congruent? So we're not talking about triangles anymore, but that's okay. We know congruent shapes, the sides are the same and the angles are the same, the corresponding sides and angles. So it looks like, I mean, they're all the same, right? All the sides are the same in both of them, and all the angles are 108, right? 108. Just double check, because sometimes they try to throw another number in there like 180. You're like, what? So yep, those are congruent. Are these shapes congruent? So they have equal angles, right? So that's check, angles are the same, but are the sides the same? No, right? These are 20 and these are 25. So these are not congruent. These are probably, yeah, these are actually something else. This is what we call similar shapes. And the symbol for similar is just this single squiggle. And we're going to learn about similar shapes soon. Similar shapes have equal angles and proportional sides. So we're going to learn about those coming up. These are not congruent because the side lengths are not the same on, corresponding side lengths. What is the value for x and y that make these triangles congruent? So let's look. Where's x? Here's x, and here's x. And the y is in the angles, right? So we want to try to solve for x and y. Because if you look at the answer choices, that's what they've done. And we know that if the triangles are congruent, it means the parts are equal. So let's match up the parts. We're trying to find y. We could look at n if you guys want to. Angle n matches with angle r. So 1.5y equals 41.4. Now we want to solve for y. Remember how to get y by itself here? This is 1.5 times y, so we're going to divide both sides by 1.5. So let's grab a calculator. Let's see if my screen, yep. I would like you guys to obviously work with your Desmos, but since I have this here quickly, I'm just going to grab my calculator app on my computer. And we want 41.4 divided by 1.5. 27.6. All right, so y is 27.6. So we know it's not going to be A, and it's not going to be C. We're down to B or D. So let's look at X. We have an X. Let me get a different color. We have an X here and here. So MN matches with PR. Ooh, let's use that one. That worked. We could not use MO because MO matches with PT. See how we don't know anything about PT? So we couldn't really use that. But let's use 3x minus 9 and 24. Now, if they're congruent, which they're saying they should prove it to me, then that means they're equal. So we're going to set it equal. And solve for the value of x that makes this true. So we want to get x by itself. We want to move the 9 over. 24 plus 9. 33. And then 3 times x. Remember, the inverse operation of multiplication is division. So x equals 11. So we found the two values that make those congruent statements true. 11 and 27.6. This is an actual SOL question from a previously released test. So you can see how most of what this problem, actually there's two things this problem is assessing. They're making sure they know that you know what this statement means, that you match up those corresponding parts. And then they're also, hey, do you remember how to solve equations? So we're going to have a little bit of algebra mixed in with our geometry. Here's our last example. Given that these triangles are isosceles, which we haven't explicitly talked about in class yet, but I bet you can look at these pictures and tell me what is an isosceles triangle. It's a triangle that has two equal sides. See, this one and this one are equal. Two equal sides. What measure of angle P could be used to prove these are congruent? So it's a similar style question as the one before. We have this statement, and we're trying to find the measure of angle P. Here's P. What does P match up with? P matches up with L. So we don't know anything about P and L yet. So we got to work with what we do know. We know M and Q. We don't really know them, but they're marked, right? They have something there. So that's the only thing we can really work with. And thankfully, in the congruent statement, M and Q are in the right position. So that must mean they're the equal. So let's set them equal and solve for x. We're going to get all of our x's together, so let's move this x over to the left. 2x minus 1x is 1x. And I'll just bring everything else down. My pen is working really well today. Very excited about that. All right, we're going to get this x by itself by adding the 26 to both sides. So x equals 42. So that's the value of x. Again, we don't really know much more, right? We don't know L, we don't know P. Let's just do the next natural thing. Let's take the x and plug it in. Let's see what these angle measures are. So 42 plus 16, that's 58 degrees. And 2 times 42 minus 26. Woo, let's get a calculator. 4, hold on. 2 times 42. Where'd my calculator go? Did I close it? I must have closed it. 2 times 42 minus 26. Ha! Now most of you may have been going, it's 58 degrees. And we know that's true, right? Because these angles are corresponding. They match up. Plus we set them equal. And so we would have known that they're both 58. But I just wanted to make sure. All right, we still don't know anything about L or P. Any ideas? I'm wondering what you guys are thinking. The only other thing we know about these triangles is that the two sides are the same. So this is equal and this is equal. And something that's special about these triangles is if the sides are the same, so are the angles across from them. They have to be. And that makes sense if you think about it when you're forming a triangle. If you have two side lengths that are exactly equal, when you go to form that triangle, see, of course they're going to make that same angle with the base because they're the same length. So they have to be the same measure. So that's a really special and very helpful thing for this problem because let's see, we already have 58 degrees. How many degrees are left to fill this triangle? We know there's a total of 180, right? Let's take away the 58 and see how much is left. 180 minus 58, 122 degrees. So we have 122 degrees left to fill these two angles. And since they must be the same, all we're going to do is divide this by 2. That's 61, pretty sure. Yeah. So each of these angles must be 61 degrees. And again, that's because the sides across from them are the same, which we knew because they were marked. And these are going to be the same. Ooh, 61. 61, because they're corresponding. So our answer is C. This was a really cool problem. Very interesting, very multi-layered, lots of steps, not so much on the paper, but through our thought process, right? This is the kind of problem that really drives home the idea behind problem solving skills, right? It's like what we talk about all the time. And you guys hear your teacher say that word all the time. I say it a lot. But the steps that we took to work through the problem are what we're working on, is what we're learning here. So there was really only, this one quote unquote math problem. And then over here, the math problem. All the rest of it was that big brain stuff where we think through what's happening, we think through what they gave us and what's missing. I love this problem. You guys, that was a really short play pause it. Not planned. Don't get used to it. But I am truly looking forward to seeing you on Wednesday. And I'm curious if anybody still plays this game because last year it was definitely very popular. So I'm curious if you guys still play that. I will, again, I'll see you Wednesday. Reach out if you need any help. I know I've had a few questions already on the constructions assignment, so we can go over a little bit of that maybe in class. And then also I'll be available in office hours if anybody wants to work through the constructions quiz in office hours. I hope you guys have a great week. Bye, everybody.